Yeah, good evening all and welcome back to the 12th week of TA live sessions for AI SMPS. Before we get started, can anyone confirm if my audio is clear and if my screen is visible?
Yes,
Okay, great. Thanks for confirming. So, yeah, this is the final week of the TA live sessions. We today we'll be discussing some questions from the last week of the course, which involve some constraint problems, right? Constraint satisfaction problems. So we'll have a look at topics and questions based on that. And then on 16th, if I remember correctly, we will have an extra session. So any extra doubts that you might have, you can let me know today towards the end of the sessions. I already have some of them noted down from the previous live sessions, and hopefully we will get time to discuss that in on the extra live session day, which should be on 16th. But you should receive a notification from the Swayam team or the NPTL team. Okay, but that's for the next session. For today, let's get started. Okay, so this is the first question for you. Okay, let me walk you through it. So the question says that a cryptarithmetic puzzle is an arithmetic problem in which the numerals have been replaced by letters. That is, each numeral has a distinct letter assigned to it, and each letter stands for a unique numeral. Okay, every number has to be non-zero. Okay, and the task is to find out, every number begins with a non-zero numeral. The task is to find out what each letter stands for such that the arithmetic problem has a solution. In general, cryptarithmetic puzzles may not have a solution, or have one solution, or have multiple solutions. Okay, so here the puzzle given to you is this: jab plus jab equals good. What you have to do is find a mapping for each of these alphabets with a number, okay, such that this whole equation remains valid. And let me show you some examples of that, for so that you can get started easily on that. So let's say we have this equation. Okay, let me actually use something else. Just give me a moment. Okay, so if you had to replace a, x and y with um, some numbers such that this equation holds true, what could be potential replacements for or mappings for a, x and y? Dhruv, just to clarify, I am not aware about the logistics related to the exam. So any questions like exam date, exam pattern, marks distribution, or anything should be pointed towards the NPTL team. I think they will be able to address it better than me. Okay, coming back to the question. So what do you think could be assignments of a, x and y? Let's say I assign a to be 1 and x and y to be something else. Will that satisfy the equation? Anything? Yes, no, maybe? It won't, right? Yeah. So what is the minimum number that you can think of that we can use or assign to a such that this equation holds true? 5, right? So if we assign a to be 5, then we will have 5 plus 5, which will be 10. In this case, we assign x to be 1 and y to be 0. But let's say I add one more constraint. Okay, so one constraint C1 that was given to you was that you must assign these numbers, so the domain of each of these alphabets should be from 1 to 9. Okay, second constraint is that the solution or the equation should still remain valid. Okay, if I have to formalize it in terms of constraints, so these are two constraints given to you. Another constraint is that no two alphabets can have the same mapping. Okay, so no two alphabets, I'm not writing the whole thing, can be assigned the same number. Okay, so these are some broad constraints or rules that you have to follow while making the assignment. So while this does look good, this violates the first constraint that the numbers have to be from 1 to 9. So we will omit this. After 5, exactly 6 is the next number that we can assign then. So this will be 6 plus 6, which is 12, in which case we will assign x1 and y2. But is this the only possible solution? There are many solutions, right? Correct. So there can be many solutions. We can assign 7 plus 7, which will be 14. We can assign 8 plus 8, which will be 16. We can assign 9 plus 9, which will be 18. No more solutions, right? So these 4 solutions. Is there anything else that we can have? No, right? So do you get the hang of what exactly these kind of puzzles are about? This was a relatively easier example. Let me give you one more example so that you get familiarized with what exactly we are trying to do. Let's say instead of a plus a equals xy, we have something like this. If plus it equals y. This is your equation, and now you need to find mappings for I, F, T, W, H and Y. Okay, one hint that you can get from here is that if and it are 2-digit numbers, whereas the sum is a 3-digit number, so you need to assign the numbers accordingly. And you also know that the starting number of these starting the assignment of I, basically the starting value of if and it, they have to be the same because both start with an I, right? So those are 2 hints for you, but I'd like you to think about what could be possible solutions to this puzzle before we move on to the one given in the actual question.
I can do anything over 5. equal to or greater than 5.
Sorry, can you come again?
I can be given any number equal to or greater than 5.
Correct. That is true because we require the sum to be a three digit number.
Hmm.
Um, so there are a couple of suggestions in the chat box. One of them is 93 plus 92, which is 185. So let's write that down. Okay. Now this seems correct. Uh, the first digit is the same, 9. If f and t have different assignments, 93 plus 92, and then w, h and y, each of them have separate assignments, and the sum is correct. So this seems to be a valid solution. We have to be careful though that no two of these alphabets have the same assignment, right? Which is why 75 plus 76 equals 151 would not work over here. If it was allowed that multiple alphabets can have the same assignment, we could use that. Okay, we have another solution. 59 plus 68 equals 127. Let's check that. Sorry, 59 plus 68 is 127. That is correct.
That is not correct, right? Y means I should be same, right?
Oh yes, correct. So although the sum is correct, we cannot assign 59 and 68 because the starting digit is different. Thanks for pointing that out. Yeah, exactly. I value should be same. So we still haven't found any other solution. 53 and 54 are again two other suggestions. Let's check the sum. 53 and 54 lead to 107, which is okay. The sum is again correct, but then another constraint that we have is we don't want to assign any number to be 0. We want to assign numbers that are between 1 and 9. Okay, so 1 2 3 4 5 6 7 8 9, only that can be followed. Another suggestion is 69 and 68, which leads to 137. This sounds correct. Does this seem correct? So I has the same assignment, f and t have different assignments, w, h and y all three have different assignments. So this seems correct as well. We have another which is 82 plus 83. So you get the hang of it now, right? There can be multiple other solutions as well. Okay. Any more doubts about the problem setting itself? Yeah, just make sure, let me revisit the constraints for you. So 3 constraints that we have to be careful about are these. Okay, we have to assign numbers to alphabets between 1 to 9. Okay, which means we can't assign 0. Okay, we can't assign any number greater than 9. So it has to be amongst 1 2 3 4 5 6 7 8 9. Okay, this is one constraint. The second constraint is that the equation has to remain valid. Okay, we cannot write something which will violate this plus condition that is given to us. And then no two alphabets can be assigned the same number. Okay, so each alphabet must have a unique assignment. With these 3 in mind, and I hope most of you get the hang of what we are trying to do, let's go back to the question we had. So here we had jab plus jab equals good. Okay, so we have the sum of two 3-digit numbers that leads to a 4-digit number. So I'll let you think about it, and you can feel free to come up with your solutions, share your solutions, and I'll wait for a couple of minutes before we discuss the final answer. So just to answer a question in the chat, essentially what we're trying to do is find a mapping, okay, of these alphabets to a set of numbers, okay, which is our domain, which happens to be 1 to 9, okay, 1 2 3 4 5 6 7 8 9, okay. We have to find a assignment for each of these alphabets in the equation. Each of these alphabets should have a unique assignment, which means that once we assign a number to an alphabet, no other alphabet can be assigned the same number. And we have to find an assignment for all such alphabets in the equation such that the equation remains valid mathematically or arithmetically. That's what we have to do. Okay, there was a hand raised. Is there any doubts about this one? Okay, maybe it was by mistake. So I'll just wait for a minute or so, and then we can have a look at the solution. So I have a couple of assignments in the chat box that I can see. We'll make a note of them and we'll revisit them in a while. To answer this question, what if the input is a string of length greater than equals 10 with unique characters, in which case the digits assigned will not be unique? Correct. In that case, we won't give an input of greater than length 10, okay. You might have some other constraints in that case. The constraints will change, the problem will likely change, okay. So these examples that we are looking at, these are simple examples of constraint satisfaction, okay. In real world, where we have to solve problems with a large number of constraints, more complicated constraints, we have specific algorithms for that, which we can use to find an optimal solution that satisfies all the constraints, okay. So I see a lot of solutions in the chat box that seem to violate some of the constraints that we had discussed, okay. So I'll reiterate the constraints. Each alphabet must be having a unique assignment, which means if A is assigned a number, B cannot be assigned the same number, G cannot be assigned the same number, okay. This is very important. Second constraint that is important is we cannot assign any alphabet the value 0. 0 is not something that is available to us. So we have to assign between 1, 2, 3, 4, 5, 6, 7, 8, 9. All alphabets should have a unique assignment, okay. The sum also should not have a 0 in it, okay, because if we are having a sum value with 0, which means that we are assigning a 0 value to some alphabet, right? These are two important constraints. The third constraint, of course, is that the equation should remain valid. Okay, so let's go over all these solutions one by one that some of you have posted, okay. So 614 plus 614 or 612 plus 612, I think some of you have posted. Those, they seem that they are okay, but actually they are violating one condition where you are assigning A to be 1 and then you are also assigning G to be 1, okay, which is violating the constraint that no two alphabets should have the same assignment, okay. Similarly, there are some of you who have assigned a 0, right? So that is also not valid, okay. Some of you have assigned the same number to both J and A, again that is also not valid, okay. So let's see.
832 plus 832 is correct, I think.
Yes, there are some of the solutions provided which we could actually use, so let's write that down. So we have JAV plus JAB equals good. Okay. Now one thing that we can observe from here is, again, we are adding two 3-digit numbers and getting a 4-digit number, right? What is the maximum value that we can assign to this jab if we were not given the constraint of this equation being satisfied? Okay, the maximum value that j could have is 9, right? Because we want the number to be as high as possible. Because 9 is already assigned, we could give 8 to a and 7 to b. 987 is the maximum that we could do without looking at the good part of the equation. Okay, so we are neglecting this part as of now. But in any case, if we had to do 987 plus 987, we would get a 4-digit number with 1 in the fourth place, right? Unit, tens, hundred, thousands place of the decimal. So we know that no matter what assignment we make, g is supposed to have a 1. Is that clear? That is one hint. Okay, now you can try to fill in with this information in mind. Let's say you did assign.
Can you repeat why G should have 1?
Okay, so the logic that I followed for that is you are adding two 3-digit numbers. Okay, if you hit this part of the equation, you are not looking at good. Let's say you are only concerned with the two constraints that you had initially, which is unique assignments, and assignment should be from 1 to 9. What assignment could you make to this jab such that the number that you got, the 3-digit number that you got, was the maximum possible number that we could assign? What would you assign to j in that case? It has to be a 3-digit number, so it has to be less than 1000, right? So it has to be in the 900s. Do you agree with me?
956.
It should start with 9, but then you could assign something else to a and b, right? There are 3-digit numbers greater than 956 as well.
Okay.
What's the immediate number integer after
988.
98, right? And then after 8,
7.
7. So if we hit this part for now, okay, the maximum number that we could get out of jab is 987, correct? Now if we do 987 plus 987, what do we get?
1974.
19. Can you tell me again?
1974.
74. This is the maximum sum that we can get out of all assignments we could ever make. Correct? You agree with me?
Yeah.
So any assignment we are going to make will be lesser than this. Correct? Because we know this, any assignment will be lesser than this, and at the same time we also know that the sum is supposed to be a 4-digit number. It has to be greater than 1000. Correct? So it has to have 1 in the 1000 decimal place.
Okay.
Correct? You agree with me?
Yeah.
Yeah. So that is the initial logic we followed. Now let's try to fill in the other values that we had. So let's say we start with the maximum value that we could assign. Let's say we assign 9 to j. Okay, and we know that g will have 1. Okay, we also know two other things. First is that no matter whether b is even or odd, can you tell me whether d will be even or odd? Even, right? Because irrespective of whether b is even or odd, the sum of those will always be even. Correct? So we know that the last digit, the units place in good, that will be even. So that reduces our domain as well. What if we assign a to be 4 and b to be 3? What is the sum that we will get?
$1886.
Correct? Is this a valid assignment?
Yes.
Yes, right? So this seems to be a valid assignment. Okay, let's go. Is there, first of all, is there any other combination in the 900s that we could try? So yeah, so here is one trick. You have to be careful that O has to have a consistent assignment. Okay, so I see a suggestion about 923 plus 923, but that will give us 1826. Here O is having two different assignments, 8 as well as 2, so that won't work. Okay, so you have to be careful about those. Similarly, we can't do okay, can we do 942 plus 942? What will
Yes.
that give us?
Yes, works. 188. 1884.
No.
Only the last digit will change, not so it is still fine.
No. 1884.
But we are assigning A to be 4 and also D to be 4. So this is also not valid.
Oh,
Correct?
Yes.
okay.
So it turns out that actually there is no other combination in the 900 series that we can that will give us a valid solution. Okay, you can verify that later. But for now, let's go to the 800 series now. Let's assign 8 to J. G will still remain 1. What is the other thing that what can we assign to A and B? I see some solution in the chat box about 832. Would 832 be a correct valid assignment?
Yeah.
Yes.
Let's write that down. So what will that give us? 1664. Am I correct? Does this satisfy all the constraints given to us?
Yes.
Okay, so this is also valid. And similarly, there's no other assignment in the 800 series that will give us the solution. Is there any assignment in the 700 series that will give us the solution? Seven two three plus 723 is a suggestion that I see. Let's write that down. That will give us 1446. Okay, this also seems like a valid solution. So all these three are valid. As per my knowledge, these three are the only possible solutions to this equation. Again, you can verify this as per your time. So here we kind of took a ad hoc approach to solving this. Okay, we did start correctly. We had some hints about what we could what could be the domain of the different alphabets, right? We narrowed down that J has to have a value such that we get a 4-digit number in the final sum, right? So we eliminated anything that is lesser than 5, right? We also made sure that 0 does not get assigned to any number. We also made sure that D has an even number, right? So that reduced our search space slightly. So those were some strategies that we did, and we did some hit and trial to see what could be the possible assignments. Okay, again I see some suggestions in the chat box. Please make sure that the constraints are satisfied. Okay, so the whole topic of discussion in this week is constraint satisfaction. So yeah, each alphabet have to be assigned a unique value. So you cannot have two alphabets with the same value, so that will eliminate 614 plus 614. Okay, Um, so this we could actually do by solve by hand, okay, by spending some time looking at the various combination that could happen. But let's say we want a formal method to reduce the domain set so that we have a formal assignment um, for each of the alphabets or for each of the variables in the constraint if you have to generalize it even further. So for that we are going to look at some algorithms next, okay. But before that, is this question alone clear?
Yeah.
Yeah, writing a program will help to find all possible solutions. True. uh, so I would actually encourage, if most of you are comfortable with programming, um, you should try implementing all the different methods or algorithms that you have learned in this course. It's not a necessary thing, it's not a requirement, because I don't think you will have implementation or programming based questions in your exam, but it will really help your understanding of the algorithm if you try to implement it on your own. Okay, so I would highly encourage that. What we could also do is in the extra session that we have on Thursday probably, I could show you some of the implementation that I have for existing methods. So some of the methods we have discussed in the course, like A star or this constant satisfaction problem, in fact. So I have the implementation for them. We can try out some of them, um, like a hands-on sort of thing. Okay, but that is for later. But for now, let's move on with the questions for today. Okay, so let's have a look at the answer for this one. So does the puzzle have a unique solution? This is the first question. So what would you say? No, right? There we saw that there are at least 3 solutions and maybe only 3 solutions. Okay, is the value for the letter G unique for the above puzzle? If your answer is yes, then enter the value, otherwise enter nil. So what do you think would be the unique value for G?
Yes,
Yes.
only one.
Yes, and 1, right? We just discussed how. And is more than one value possible for the letter J in different solutions? Again, yes,
Yes.
right? We saw 3 different
Yes.
values. Okay, what can one say about the value for the letter D?
It's all even number.
Even number.
Right? So B is the correct option. What can one say about the value for the letter O?
Either even or odd.
Sorry?
Odd or even.
Odd or even.
Okay, so it might seem that it will be odd or even, which also makes sense. So if you have a look at it this way, let me again use the whiteboard. What do we have? We have jab plus jab, and we get good. Okay, so if we have to actually write it in terms of the usual arithmetic that we do, so this B is in the units place, A is in the tens place, right? And the sum of A is actually going to decide the value of O. Do you agree with me?
Yes.
Yes. So it will be, so whatever B has, that will result in D. The sum of two B's that may or may not result in a carry. Do you agree with me?
Yes.
Yeah. So if A is, let's say A is even, then it should be an even number. O should be even if there is no carry, right?
Yes.
If A is odd, also O should be even if there is no carry. But at the moment that there is a carry, O can become odd. Agree with me?
Yes.
Okay, so with that in mind, now let's have a look at the 3 solutions that we had. Based on these 3 solutions, do we have any case where O is odd? We don't, right?
No.
Yeah. So as it turns out that this specific problem leads us to the solutions that do not allow O to be odd. Because of that, we will say that it can only be an even number. Theoretically, it could be an odd number as well if this equation itself was something else that allowed this to be odd. Okay, but for this specific question alone, it can only have an even number. So this is again an example of some kind of question that you have to be careful about. There are things that are specific to this question, and there are certain things that are true in general. In general, O could have been an odd number as well, but in this specific case, it will always be an even number. Does everyone agree with that?
Yes.
Okay, great. So now we are done with the simple examples. Let's move on to a different kind of a CSP problem. Okay, and we will have a look at the specific algorithm that will be called arc consistency that you might have come across in your lecture videos. So let me familiarize you with the problem setting. Okay, you have three variables x, y and z. Yeah, Shiva, you had a question.
So we need to solve the problem what we discussed in the same way, or is there any other way?
For a simple problem like we just discussed, you can even solve it manually by hand. If it requires more deliberation, more complicated kind of a question, there are proper algorithms that you can use for that, and we will discuss that right now actually.
Sir,
Even the problem we just now discussed
Hmm.
is not that simple because we have to search so many numbers.
Yeah, so essentially you have to follow the tricks that we kind of came up with, right? For example, we narrowed down the possible. So essentially, what we want to do is we have a domain from which the alphabets could be assigned a number. Okay, and initially when we start, that domain is filled up with 9 possible numbers for each alphabet. Correct?
Yes.
And we have to find a way to somehow trim that domain so that our search space gets shorter or smaller, and we have algorithms for that. One of such algorithms is arc consistency. So some examples of kind of trimming the domain that we did initially in the previous question was narrowing down on what could be the possible values of, let's say, j or g or d, right? So we removed, for example, for d we removed all the odd possible or the odd numbers in the from the domain of d, right? We removed all numbers except one from the domain of g. So we knew that g will only have one. So essentially what we are left with only a few other combinations. For in our case, we had to try only the combinations of a and b. Okay, and then
Okay.
check whether this constraints on the right side of the equation is being followed or not. So that is one approach that I personally use to solve these kind of problems. But again, you could use proper algorithmic approaches as well if you would feel comfortable with that. Does that answer your query?
Yes. But this all comes from practice. I think we have to request the practice.
Yes,
Few examples and all will try.
of course. Practice is always required, of course.
Okay. Okay.
Yeah. Okay. Okay, so let me try to familiarize with you with the problem setting that we are going to deal with next. So here we have three variables, okay, x, y and z. Okay, so let's write that down. We have x, so corresponding to each variable we will have a domain. Okay, let's denote that with this oval over here, and let's denote it with the this kind of a symbol d of x, d subscript x, which basically denotes domain of x. Similarly, this is domain of y, and this is domain of z. Okay, now we are given what is the initial domain of all these three variables, which happens to be 3, 4, 5, 6. So let's fill that down. So each of these will have 4 numbers, 3, 4, 5 and 6. Okay, now let's revisit the question. Now we are given two constraints that are in terms of two relations. Okay, the first is relation between the variables x and y, okay, which is denoted by rxy equivalent to x less than y. So let's write that down. So the first constraint is x has to be less than y, and formally we can write it in the way that is given in the problem, which is rxy x less than y. Similarly, the other constraint that we have is ryz y is less than z. So these are the two constraints given to us. Now what we will do is we have to make this particular domain arc consistent. Okay, what do we mean by arc consistent? For that, let's first define what are arcs. Okay, does anyone know what will be arcs in this case?
No.
For every number in X, there has to be a corresponding mapping
Exactly.
in Y.
Yeah, that is in the correct direction. So an arc is basically a connecting line that we are going to draw between the elements of the different domains, such that using that pair of assignment of values to the of the variables concerned, the relation is, or the constraint is satisfied. For example, let me use a different number or different color, let's say green. So let's consider each number in the domain of x. Let's consider 3 first. So we know that x is related to y alone, so we only need to look at dx and dy for this constraint, x less than y. So 3 should be connected to which numbers in the domain of y?
4, 5, 6.
4, 5, 6.
4, 5, 6, correct, because x has to be less than y. So let's draw an arc from 3 to 4, 3 to 5 and 3 to 6. Okay, similarly let's draw an arc for 4 as well. So 4 will be connected to which numbers?
5, 6.
5 and 6. So 4 to 5 and 4 to 6, and 5 will be connected to 6 alone. Correct. 6, will it be connected to any number?
No.
No, right? Correct. So now there are no more arcs to be drawn between dx and dy. Now let's try to draw an arc between dy and dz that follows the constraints y less than z. So 3 will be connected to which numbers again? 4, 5, 6 again, right? Because again y has to be less than z. 4 will again be connected to 5 and 6, and 5 will be connected to 6. Okay, now is everyone convinced that these are the only possible arcs that we could draw given this set of this domain set that we have?
Yes. Yes, sir.
Correct. Now what we will do is we will use this algorithm called arc consistency. Okay, let me show you that algorithm. Yeah, so you might have come across this in the lecture videos. Basically what we want to do is, this is a function, okay, and we are trying to make arc consistency, or we are trying to revise the arcs in the x to y direction. Okay, the direction of this function is very important, it has to be fixed. Let's start from the beginning. Okay, let x comma y be an edge in the constraint graph of a network R. Okay, so in our case xy could correspond to any of these edges. Okay, 3 to 4 or this 3 to 4, any one of them. Okay, variable x is said to be arc consistent with respect to variable y. So remember that here x and y correspond to some random two variables. Okay, this x and this y are not the same as our x and y. These are two general variables. Variable x is said to be arc consistent with respect to variable y if and only if for every value a in the domain of x there is a variable b in the domain of y such that a and b satisfy the constraint between x and y. Is this statement clear to everyone? Any doubts in this statement?
Clear, sir.
Clear? Everyone?
Yes.
Great. Okay, the third point now says x can be made arc consistent with respect to y by using the algorithm revise. And what is the algorithm revise? For every element a in the domain of x, we will see if there is no element in the corresponding domain of y such that the constraint is satisfied. If there is an element in the domain of x for which there is no connection to the domain in y, we will delete that element from the domain of x. Okay, and this is, remember, this is happening in the x to y direction, not y to x. If we do y to x direction, then we would be removing elements from whose domain set. Okay, let me try to show you through this figure that we had drawn. So what the revise algorithm is telling us is, we will have a look at, so revise x to y. X comma y. Okay, remember x is in the first position of this argument list, y is in the second position of the argument list. So we are doing this revise operation in this direction. Okay, so what we will do is, we will have a look at all the elements in the domain of x, because x is in the first position of this revise operator, right? For each element in domain of x, we will see whether there is a corresponding element in the domain of y for which this element is related to that element by satisfying that constraint. So for example, for 3, is there at least one element in the domain of y which is related to 3?
Right.
There is, right? We have 4, 5, 6, 3 elements in the domain of y that are related to 3. Is everyone convinced about that? Any doubts there?
No doubt.
Okay, great. Okay, so 3 is clear. What about 4?
Yes, there are two elements.
There are 2, right? So there is at least one element. For 5 also there is at least one element. Actually there is exactly one element. For 6, do we have any element in y for which they are related?
None.
None, right? So what revise will, this function revise, what that will tell us is, remove 6 from the domain of x. Okay, now do you correlate this with something that we were doing in the previous question? We were also trying to trim down the domain, and this algorithm is also formalizing a way to trim down the domain of different variables. Do you follow that comparison?
Yeah, reducing the search space. Anyway.
Exactly, we are trying to reduce the search space. So this operation, this revise operation that we did it in only one direction, right? We only checked dx to dy, but that doesn't necessarily mean that the whole network is arc consistent, correct? So to do that, we'll have to do some more checks. Okay, so I hope this function itself is clear to everyone. Any doubts with the revise function itself? Okay, great.
Now,
Yeah, was there a doubt?
in the dy, 3 will be existed because the condition is x was less than y.
Hmm.
Then in the dy, 3 will be there after revising it.
Hmm. Revising it in which direction? Are you inputting revise x comma y or revise y comma x?
X comma y.
So when we are doing x comma y, we will only remove elements from the domain of x.
But the condition won't satisfy, no, ma'am. If we are considering 3, at that time in the y 3, 4, 5, 6, is it possible?
So okay, so let me go over the revise function again. What revise function tells us is that, again, revise x comma y. When we are looking at x comma y, we will only look at the domain of x, and we will see for every element in the domain of x, is there at least one corresponding element in the domain of y which is related to this element. So
Okay.
if this was the domain of x and this was one element in the domain of x, we will check the domain of y only to see if there is a corresponding element b over here such that a and b are related. There could be another element, let's say p in here, that may
Okay.
not be related to a. We are not concerned with that as long as we are doing revise x comma y. The only thing that we
Oh,
are concerned with is a should have at least one element with which it is related, and that b should be in y.
okay, okay, ma'am. Thank you.
Okay. So let me erase these things. Okay. Okay. An edge x comma y is said to be arc consistent if both x and y are arc consistent with each other, achieved by cos to revise x comma y and revise y comma x. Okay. So in order for us to say that an edge is consistent x and y, we need to do the revise operation in both directions, x to y and y to x. So essentially what we need to do here is, currently we applied the revise operation only in this direction. We need to do that in this direction as well. Now when we do the revise operation in dy to dx direction, we will look at the elements of y one by one. I had not shared my screen. So what I was saying is that the first step that we did was we checked the we applied the revise operator or revise function in dx to dy direction. In a second step, we will apply the revise operator in dy to dx direction, and in that case we will look at the elements of dy. So when we look at the elements of dy, which elements in dy are not connected to any element in dx?
3,
3, right? 4 is connected to 3, 5 is connected to 3 and 4, 6 is connected to 5 and 4 and 3, but 3 is not connected to any element of dx. So this algorithm will tell us remove 3 from the domain of y. Is that clear?
yes,
Yeah. So notice here that now we have checked the arc consistency of all the edges between dx and dy, but we still haven't checked the arc consistency of edges between dy and dz. So next, what do we do?
Same logic to be applied. And reverse, we have to validate in the reverse direction also, no? Z
Yeah,
to y.
exactly. So the next step that we are going to do is apply revise in dy to dz, and then again apply revise in dz to dy. Okay.
In that case, 3 will be less. Right?
Yeah. So when we do dy to dz, which element will be removed?
6.
6 will be removed, right? Because this doesn't have any connection to any element in dz. So 6 is removed now. And when we do dz to dy, which element from dz will be removed?
3.
3, right? Because this does not have any connection to any element in dy. So now that we have applied the revise action or revise function in all possible directions in this constraint graph, let us redraw this graph with the trimmed down domains. Okay, so now we are left with 3, 4 and 5. And in dy, what are we left with? 4 and 5 only, right?
Yeah.
And then what are we left with in dz? 4, 5, 6 again.
Yeah.
Okay, now I want you to apply the whole pipeline that we just discussed to this domain set again and tell me what are the updates that we are going to make. Okay, I'll wait for a couple of minutes for you to try to solve this.
5 should get removed.
Yeah, 5 should be removed.
5 should be removed from which domain?
DX.
X, dx.
Okay. Any other element should be removed from any other domain?
4 should get removed.
4 should be removed in DZ.
Correct. 4 should be removed in dz. Correct. So let's try to do that and see whether all these will be removed or not. Okay, so let's use the same color coding. We use green for dx to dy. So 3 will be connected to 4 and 5. Correct? 4 will be connected to 5 only, right? And 5 will not be connected to anything. Similarly, in dy to dz, 4 will be connected to 5 and 6, and 5 will be connected to 6. These are the only arcs that we can draw, right?
Right.
Okay. Now let us apply the revise function in all directions as we discussed. So first in dx to dy direction, which will remove 5 from dx. Yeah, because there is no element connecting 5 to any other element in dy. Next we apply dy to dz. Will this remove anything from dy?
No.
No.
No, right? Because for every element in dy there is at least one image in dx. So no removals from dy. Next we will do dy to dz. Will this remove anything from dy?
4.
No.
It won't remove anything, right? Because 4 is connected to 5 and 6. Yeah.
Right.
And then dz to dy,
4 will be removed.
4 will be removed because 4 is not connected to anything in dy. So again we have made some corrections. Now let's redraw again our domain again once more. So now in dx we are left with only 3 and 4. In dy we are left with
4, 5.
4, 5. And in dz we are left with
5.
5 and 6. And if we draw the arcs now, 3 will be connected to 4 and 5, 4 will be connected to 5, and for y to z, 4 will be connected to 5 and 6, and 5 will be connected to 6. Now if we apply revise again, yeah, sorry, is there a doubt? Okay, maybe not. So now if we apply the revise operator again, will anything be removed or not?
No.
No, right? No more removals. So at this point we can say that this whole network has been made arc consistent. That is, every edge in this network now is arc consistent. And now we have also pruned the domain well enough for us to trivialize this problem. Now we can manually by hand choose values from x, y and z, or for x, y and z, that will satisfy the constraints given to us and find an optimal solution. There might be multiple solutions. For example, you could assign x3, y4 and z 5. That will still satisfy, or you could assign x3, y4 and z6. So there could be multiple solutions, but any solution we choose from here is supposed to satisfy the constraints given to us. So does everyone understand the revise function and the arc consistency problem that we just solved here?
Yes, sir. Please.
Okay, great then. So now let's look at the questions based on these couple of this couple of things that we have just done right now. Okay, so the first one tells us draw a matching diagram before answering the question 6 to 8. So matching diagram is nothing but the network that we just drew. Okay, so this will be the initial matching diagram. Okay, then you will refine, then it will be reduced to this will be the final. Okay, this is the thing. And it has said that your answer must be a comma separated list of domain values in ascending order. So this you can have a look at. What is the question? The question tells us for the given CSP, the value of dx after the network is made are consistent is. So what will be the answer here?
Okay. 3 and
3
4.
and 4.
3 and 4,
Yeah.
correct.
3 and 4.
Yes, 3 comma 4. Remember that you have to put the answer in this particular format, right? Which is suggests, right? Comma separated list of the domain values in ascending order. So so that's why we wrote 3 4, not 4 3. Okay, so be careful of these things in your assignment and exam. Okay, next question. What will be the value of dy after the network is make r
4, 5.
4 5? Great, yeah. And similarly for dz
5, 6.
5 6.
5, 6.
Correct. So we now have some understanding of trying to solve a constraint satisfaction problem using the revise function and the arc consistency method that we just saw. Okay. Okay. This is the final slide that I had for today. But before that, I have a couple of more questions. So let's go to those first. Okay, so this is another problem that you had a look at. Now let me pose another problem to you. Okay, so how many of you have heard about the map coloring problem?
Yes, I am.
You have heard, right? Okay, so essentially what we have there, okay, before that, is there a doubt? Shiva, you had raised a hand.
No, I want to say that I know map coloring.
Okay, yeah, great. Yeah, so I think most of you would be familiar with it, but just for the sake of completeness, let me go over it. So Dhruv, you want me to go over the revise function once? Let me do one thing. Let me pose the problem that I am about to pose, and then let's discuss the revise function again. Okay. So basically what it says is that you have different cities or countries or parts of a map, let's say. Okay, those are denoted by different alphabets. So let's say we have A. Can you please mute yourself if you don't have a question? Thanks. Okay, so let's say we have A, B, we have C, D. So there's reason I'm drawing this as circles or oddly shaped circles, if you may. E and F. Okay, so let's say we have 6 different parts of a map, and we have some connections between these different parts. Okay, so we are told that A is adjacent to B. Okay, in the map, let's say these are 2 neighboring countries. A is also adjacent to C. A is also adjacent to D. Okay, B is adjacent to C, C is adjacent to D, and C is also adjacent to E is adjacent to D, and finally D is adjacent to F. Okay, so these are the different connections of the countries or parts of the map that are adjacent to each other, denoted by this edges that I have drawn over here. What we have to do is, we are given three colors R, G and B, red, green and blue. Okay,
You are in mute.
yeah, I just unmuted myself because I was testing out whether the recording is happening properly. So an issue that happened with the last recording is, so if some of you also attended the previous live session, we were facing some problems with the recording software last time as well, and I tried some things, and then although it did the recording, but it got stuck at a single screen. So I think some of you might have noticed that in the previous recording that I uploaded on YouTube, and I wanted to make
Yeah.
sure that that doesn't happen again this time. So yeah, I hope it's all done now. let's see, let's hope for the best. Yeah, it seems like it's recording the current screen, so it should work. Yeah, of course. So Baswaraj, to answer your question, yeah, you can get the recording through Swayam. There is a link given in the Swayam for the problem solving session. There you'll find the links to all the previous recordings, and yes, I will upload the session today itself, Pujita. Okay, coming back to the
Thank you.
problem that we were, yeah. Where were we? Yes. Okay, yes, so this is a map of countries given to you. Okay, these are the adjacent countries denoted by the edges, and the domain for all of these nodes or countries is the same. You have R, G and B. Okay, red, green and blue. You have to assign one color to each of these countries, but you have to make sure that no two adjacent countries have the same color. Okay, so for example, if you assign A to be R, you cannot assign B, C or D to be red as well, because they are adjacent to A. Okay, so is the problem setting, are the constraints clear to everyone?
Yeah.
Okay, so now that the constraints are clear, I will give you an initial starting point, okay, an initial assignment to some of color to some countries, and based on that starting point you have to fill up all the other countries with their colors such that all constraints are satisfied. Okay, and that starting assignment is, we assign A to be red and we assign B to be blue. Okay, with this I would like you to try to fill in all the other mappings, and I'll wait for a couple of minutes before we discuss the solution. Okay, in the meantime, so there was a doubt about the revise function, I think that Dhruv had asked. So let's revisit the revise function once. So Dhruv, essentially what revise is doing is, so let me just work over here in the background only so that the others don't get disturbed. So basically, given two domains, right? Domains are essentially basically values that a variable can take. Okay, let's say there are different values in this domain of X, let's say, and this domain of Y. Okay, let's say there is one variable, one value that X can take, and that value is A. Okay, there can be other values as well, they can be A, B, C, D, whatever, but let's say we are considering one of them. Okay, A, and next we will see that is there any value in dy, let's say there is something called P which is connected to A. Okay, if A is connected to at least one element in the domain of Y, we don't need to remove A. If A is not connected to any element in domain of Y, which basically means that this element A in the domain of X will never be assigned in any solution of the constraint satisfaction problem. That is why we are removing a from the domain of x, and that is exactly what the revise function is doing. Okay, this is a single operation application of the revise function. You have to apply the revise function in every direction possible. From, for example, just now what we discussed was from x to y direction, which is where we modify the domain of x. You also have to modify the domain of y, which is this direction. So you have to apply this revise function in all directions to make sure that your whole network is arc consistent. Okay, that is the revise function. Does that resolve your query?
Yes.
Great. Yes, A has 3 adjacent edges, but then those edges are also connected to some other, those nodes are also connected to some other nodes, right? So that will kind of reduce the domain of the different nodes that you have. So I'll give you one hint, okay? Think of it in this way. Let me remove this initial assignment, and let me also remove the width of my pen. So initially you put RGB in each of these nodes. That doesn't mean you are assigning RGB to each of these. It just means that this represents the domain at the very beginning, before even the assignment that I told you.
It's like Sudoku game.
Exactly, it's like Sudoku game. There's a very good example actually, Shiva. Thanks for that. So Sudoku is a problem with more constraints, more complicated constraints. There, what you have is, if you have a 3x3 Sudoku, that is, as in each compartment is 3x3, then you have to make sure that in the whole Sudoku, which is in all the 81x81 cells, for each cell, that whole column has all values from 1 to 9, all row has all values from 1 to 9, and each compartment in itself has values from 1 to 9. So the number of constraints is many more than what we are dealing with currently. Actually, the implementation of the constraint satisfaction problem that I have is on Sudoku. So maybe in the next, the extra session, I will give a demo of the implementation. Yeah, thanks for bringing that up, Shiva. Yeah, so you can start with each of these, right? And then gradually you can cross out the elements from the domain as and when you fill in. So what we were given is A is assigned R, that is given to you in the initial condition, right? So we will cross out G and B, because we know A has to be assigned R. Similarly, B has to be assigned blue, so we will cross out R and G. Now, depending on these assignments, we will cross out the elements of the other nodes as well. So A has R, right? So C cannot have R because C is adjacent to A, so we will cross this out. B cannot have R because it is adjacent to A, but R is already crossed out in B, so we don't have to worry about that. D also cannot have R because D is also adjacent to A. Correct? Similarly, you can propagate this for B. We know that this node B has blue assigned to it, so C cannot have blue. Correct? And A cannot have blue. Blue is already crossed out for A. So now you have pruned the domains partially for some of the nodes. Does that leave you with an assignment for C? Right? Once you have an assignment for C, you can again prune the domain of E and F and so on. Sorry, was there a doubt?
C can be green, sir.
C can be green, exactly. C can be green only. Okay, so I see some of you have already given the final solutions. So that's great. Um, okay, so I'll just wait for maybe a couple of more, let's say 1 minute more, and then we can discuss the full solution. Okay. To answer a doubt in the chat box, um, yeah, thanks for pointing that out. It's actually red. Yeah, pardon my bad handwriting. It's red, green, and blue, not V. Okay. Um, and I am not aware of any official WhatsApp groups per se regarding exams. At least no official groups. Okay. If there is a WhatsApp group, it's unofficial, and I will suggest join it at your risk. Okay, that is not monitored by any NPTEL or any authority. So the preferred medium of communication is um, um, a discussion forum. Okay. Yeah, thanks Dhruv. So yeah, thanks for correcting that. Okay, so it's 7:20 already. So let's discuss the solution. Okay, I was about to wait for 1 minute, but I guess I took the 1 minute. So okay, so C will have green. Okay, so if C has green, can D have green?
No, B.
No. So we will remove green from D, and we will also remove green from E. Correct?
And B.
Yeah, and B as well. B, for B it is already crossed out. Green is already crossed out for B. Okay. So now we
At
have,
E, she is telling to remove E.
Yeah, E, B should be cancelled.
yeah, in E I have cancelled green, right? Oh, you mean B? Correct. Yeah. So I was about to arrive at that. So we have now assigned values to A, to B, to C, and we are also left with only one possible assignment for D. So we will also assign blue to D, right? And because of that, we will remove blue from E, and we will also remove blue from F. So here we are only left with red for E, right? And we are left with two possible values for F. Now can you confirm if we have arrived at a mapping that satisfies all constraints? Is there any contradiction that is happening here?
No contradiction.
No contradiction, right? So actually we have found the solution. Okay, all of the nodes A, B, C, D and E have a single assignment. Only F can have two possible assignments, right? So so the solution could be, the solution could be A has red, B has blue, C has green, D has blue, E has red, and F has red. Or an alternate solution could be this part remains the same, so ditto, but this becomes F has green. Okay, two unique solutions for this mapping problem. Okay, everyone agreed?
Yeah.
Yeah. So this is what we just did. This is nothing but the select value forward checking method that we discussed. You might have come across this. This, by the way, is from a previous assignment. Okay, so don't think this is from your current assignment. I hope this is not from your current assignment. I hope they haven't repeated the questions. If they
I
have,
guess it's repeated, sir.
sorry,
I think it is repeated.
it's repeated. Okay, then I think we have solved a part of the assignment and we can't do anything about it. Okay, I should have checked that before. Okay, then in that case, I will not discuss this any further. Okay. Cool then. So that was all about constraint satisfaction that I had for today, and that concludes all topics that we have in this course, or almost all of them. And again, I would emphasize that this is also one of those weeks that is more scoring. Okay, so try to make the most of this week, like the past couple of weeks as well. And so again, to emphasize what I was, or kind of reiterate what I was saying at the beginning of the session, we will probably have an extra session from on Thursday of this week at the same time. I'm not sure why that hasn't yet been announced from the NPTEL team. I hope they announce it sooner so that more of you are aware of it and can join that if you have any doubts. But just for the uh, few of you who are there in the meeting currently, I just want to reiterate that we are having an extra session day after tomorrow at the same time, where we will discuss some of the questions that you guys have pointed me to over the past couple of live sessions. I had made a note of that, and I will try to frame questions based on all of those, if or most of those, if not all of those. You can still use today's session to point me to some extra questions that you would like to be discussed, but if not,
Sir, can we tell what to be included in next problem solving session and discussion form also?
yeah, of course, you can use the
Okay, sir.
discussion forum as well, but try to do it by tomorrow afternoon so that I have some time tomorrow second half to prepare for those.
Okay, sir.
Okay.
Week, week 9, sorry,
Sorry.
week 11, week 11, question number,
Week 9 question 11, is it, or
no, week 11, question 11.
week 11
So the
question 11?
answer, yeah, my answer is wrong, and just wanted to understand. Maybe next time we can discuss it.
Of course, yeah, I'll make a
Yep.
note. And there's also a request for week 9 question 11, so I'll note that as well.
Sir,
Yeah.
week 5 practice assignment TSP BNB part 2. Can you also
uh,
explain about that?
yeah, does that include a week 5, is it?
Yes, sir. Week 5 practice assignment TSP branch and bound part 2.
Okay. Week 5, I think I had noted that before also, but I'll just make a note of that again. Week 5 branch and bound part 2.
Yes, sir.
Practice assignment, is it a number?
Sir, practice assignment.
As in practice assignment 1, 2, 3, any of those?
Week 5 practice assignment TSP branch and bound part 2.
Okay. Cool.
Okay, sir.
Okay, anything else from your side?
So, what kind of question should we focus on for the exam purpose? Technical problems or theory based?
So it will be exactly similar to what you have been solving in the per week assignments. Okay, so again, I would like to emphasize that I am not involved with the question framing team for the course, but till now, whatever I've heard through the past semesters, what has been happening is that the exam would be just a small version of the assignments that you have been facing till now in all the weeks, just that it will cover all the topics from all the weeks. So the format
Okay,
will
sir.
be, yeah.
How many questions and duration? Any idea?
Oh, that I don't know. I think 3 hours, but can anyone confirm that? Has anyone taken these exams before?
In
Not this
discussion form,
exam. Yeah,
Bhaskaran sir already mentioned
Uh-huh.
how many hours, what type of questions, how
Okay.
many 1 mark questions, how many 2 mark questions, how many 3 mark questions.
Oh, that's awesome.
Uh,
So maybe
yes,
you
yes.
can.
The people you can check in the discussion form.
Okay, yeah. Thanks for that, Shiva. Yeah, that's great. So please do check the discussion forum where
Thank
Bhaskaran sir
you.
has shared that.
Sir, so first you recommend reviewing the assignment problems for
Assignments,
the exam.
I would say assignments as well as the practice assignments, the graded as well as the practice assignments. I think if you practice all of those thoroughly, you should be in a good position. And for any extra practice, of course, you can use the questions we discussed in the live session, or if you can get hands on any other practice questions from your colleagues who might have taken, or seniors who might have taken the course before, that's also an option. But yeah.
Sir, can we find the recorded section videos in the SWIME app?
Yeah. It's there. It's already there. I mean, not the current session, but for all previous sessions, it's already there. So let me just point that to you also.
Okay.
Over here. So you see this recording link over here?
Yes.
Yeah. So just click on that. You can find all the recordings. It will lead you to a Google Sheet. You'll find all the recordings there. I'll add today's recording by tonight.
Okay. Thank you.
Yeah. Okay, so yeah, thanks Shiva for sharing the breakdown of the exam. It will be a 3-hour exam version of the 3-hour version of the weekly assignment, similar question patterns. 65% will be 1-mark question, 30% 2-mark questions, 5% 3-mark questions. So thanks for sharing that, Shiva.
Thank you.
Okay. Unless there is any other specific question that you have, I would just like to conclude with very
Sir, can you show me the link again, that recordings?
Yeah, sure. Yeah, so if you go to Swayam, there is this problem solving session section over here. You just click on this recording link over here. It will lead you to this page. Again, click here. This will lead you to a Google Sheet.
Okay.
You can find all the recordings over here and the slides as well. Yeah, so I just wanted to say that irrespective of whether you will be able to attend the extra session or not, just all the best to all of you for the exam, and in general for whatever you want to pursue in future. I hope the course was of some help, and yeah, I wish you all the best.
Thank you, sir. Thank you all.
Hello.
Yeah.
Week 10, 14 and 15 questions.
Week 10, 14 and 15, is it?
Yes.
Okay.
Thank you very much for your time and efforts.
Thanks for attending all these sessions.
So next session you are saying it will be on
Sir,
Thursday.
exam date.
Exam date I am not aware of, Narayana. Again, I'm afraid. 26,
na? 26 is the date, right?
Okay, maybe 26 is the date. Maybe, yeah, you should verify that. I am not aware of it, so yeah.
Yes, it is on 26th.
Okay, yeah, great.
Sunday.
Have you received your hall tickets?
Till last week it was not uploaded. Now we need to check.
You will get mails regarding your hall tickets.
Yeah, still I have not received.
Yeah, there is a time. You can get, no problem.
Okay, so maybe you can also take the logistic discussions offline. Unless there is an, okay, so there's one more. Sorry, request week 10 group 4 problem. I'll make a note of that.
So your next session will be on Thursday?
Yes. So basically the NPTEL team had asked me when I want to take the session, and they said that I think I was free only on October 16th, 6 to 8, which is this Thursday. So I had filled in that date, but I am not sure why it still hasn't been announced. I hope they announce it soon. So yeah, let's see. So I think from my side it's October 16, 6 to 8. Same link.
Okay.
Yeah.
Thank you so much. Thanks.
Sir, it is need to solve previous year assignments questions also?
If you get hands on that and if you have time, for sure I would recommend that. but if you don't have access to them, I think the questions we discuss in the live sessions are kind of borrowed from the previous year assignments only, so you can use them as a resource as well. But if you want to, and if you have access to the previous year's questions, please, yeah, I would encourage you to solve them.
The live sessions is enough to study, sir.
Sorry.
Live sessions are enough to study, sir.
No, I wouldn't say that. Live sessions are good to practice, but you should definitely solve the graded assignments, the practice assignments, and ideally, yes, definitely watch the lecture videos. But yeah, I would leave it up to you depending on how much time you have before the exam.
Yes, sir.
Yeah. Okay, then. Is there anything else, or should we close the session for today?
Yes. Thank you.
Okay. Thanks all for attending, and see you again.
Thank you.